Another fundamental object oriented technique is inheritance. It is used to organize and create reusable classes. Here's chapter 7 that focuses on deriving new classes from existing classes, creating class inheritance, the protected modifiers, polymorphism via inheritance, inheritance hierarchies for interfaces, inheritance used in graphical user interfaces. Inheritance. Inheritance allows a software developer to derive a new class from an existing one. The existing class is called the parent class or superclass or base class. The derived class is called the child class or subclasses. As the name implies, the child inherits characteristics of the parent. That is, the child class inherits the methods and the data defined for the parent classes. Inheritance. To tailor a derived class, the programmer can add new variables or methods or can modify the inherited ones. Here, software reuse is at the heart of inheritance. By using existing software components to create a new ones, we capitalize on all the effort that went into the design, implementation, and the testing of the existing software. Inheritance relationships often are shown graphically in a UML class diagram with an open arrow head positioning to the parent class. Vehicle car. Here vehicle is a parent class, car is a derived class, that is child class. Inheritance should create an as a relationship, meaning the child is a more specific version of the parent. Deriving subclasses. In Java, we use the reserved word extends to establish an inheritance relationship. Class car extends vehicle, which consists of a content of a particular class over here. The protected modifier. Visibility modifiers determine which class members are inherited and which are not inherited. Variables and methods declared with public visibility are inherited. Those with private visibility are not inherited. Okay, so variables and methods declared with the public visibility are inherited. Those with private visibility that are not inherited. But public variables violate the principle of encapsulation. There is a third visibility modifier that helps in inheritance situations, that is the protected. So totally we are using the three modifiers, and among these protected modifier is the that helps in inheritance in all the situations. It is a third visibility modifier of inheritance. It is nothing but a protected modifier. The protected modifier allows a member of a base class that to be inherited into the child. Protected visibility provides more encapsulation than public visibility does. However, protected visibility is not as tightly encapsulated as a private visibility. The details of each modifiers are given in Appendix F. Protected variables and methods that can be shown within a symbol with proceeding them with the UML diagrams. This is the UML diagram for a word. The name is word. Main arguments we are passing with void main, and book pages we are giving integer, and page messages, that is void messages. In dictionary, in definition is integer, and definition messages we are using the void messages. Super references. Constructors are not inherited even though they have public visibility. Yet we often want to use the parents constructor to set up the parents part of the object. The super references that can be used to refer to the parent class and often is used to invoke the parent constructors. The super references. The child constructor is responsible for calling the parent's constructor. The first line of a child constructor should use the super references to call the parent's constructor. The super references that can also be used to references other variables and methods defined in the parent classes. Java supports single inheritance, meaning that a derived class that can have only one parent class. In multiple inheritance, it allows a class to be derived from two or more classes and also it inheriting the members of all parents. Next one is collisions such as the same variable name in two parents, that is have to be resolved. Java does not support multiple inheritance. In most cases, the use of inheritance interfaces gives us aspects of multiple inheritance without the overhead. Child class that can override the definition of an inherited method in favor of its own. The new method must have the same signature as the parent's method, but it can have a different body. The types of the object excluding executing the method determines which version of the message is invoked. The parent method that can be invoked explicitly using the super reference. If a method is declared with the final modifier, it cannot be overridden. The concept of overriding can be applied to data and is called as the shadowing of variables. Shadowing variables should be avoided because it tends to cause unnecessarily confusing a code. Don't confuse the concepts of overloading and overriding. The major difference between the overriding and overloadings are overloading deals with multiple methods with the same name in the same class but with different signatures. Overriding deals with two methods, one in a parent class and one in for a child class that have the same signature. Overloading lets you define a similar operation in different ways for different data. Overriding lets you define a similar operation in different ways for different object types.